David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit you. You can also pause a video at any point and jot down notes or write down questions for our next class. Lastly, you can turn on the captions and read my words on the screen. Today's lesson covers our binomial distribution and how to use it to calculate probabilities. So no new concepts, just more practice with the ones you got in the last lesson. So let's take a look. Here's our notation. Random variable x, b for binomial expansion, n is the number of trials, and little p is the probability of a success. We have the formula over here. This is random variable x equals r, so that's the number of successes in our experiment. We find that by doing the combinatorial of n over r. Then we raise the power we raise the probability of success to the r power, and then we raise the probability of failure, which is 1 minus probability of success, to the n minus r power. And of course, I've defined our variables here. N is number of trials, r is number of successes, and little p is the probability of success. Okay, so that should be review from our last lesson. Now let's take a look at an example. Here's the probability that a person will wake up on time for school. And that's 0.9 or 90%. Now here's the question. What is the probability that x is 2, that they wake up on time twice in a week? So pause the video, see if you could write that in this form, and then maybe do your plug-in step as well. So here's a statement of our scenario. We don't need any of these words. We can just say binomial distribution, total trials is 5, probability of success is 0.9. Now this becomes a prompt. So we could have this, and that's all you would need to do this probability problem. So now that you have all this information, go ahead and try a plug-in step with our formula. So combinatoric step is n over r, trials over the successes, the number of successes that we want, that's the 2. And then it's probability of success to the r, which is again is 2, and then the probability of failure, which is 1 minus 0.9, which is 0.1, to the n minus r, which is 3. Now pause the video, evaluate the combinatorics, do the math, and get your answer. Okay, my combinatorics, I put that over here. So if you're not sure how to do that, pause the video, take a look at my work there, make sure you can do it. I'm not going to explain it because I want to keep this video short. So check it out. If you've got that, then we're moving back along to here. My combinatorics is 10. 5, 2 gives me 10. 0.9 squared is 0.81. 0.1 to the third power is 0.001. Multiply those through, and that's my probability that this person will wake up on time exactly twice in a school week. So I got my 5 because we're talking about waking up on time for school. So there's only 5 trials. You don't have to wake up on time for school on Saturday or Sunday. So that's where the 5 comes from. All right, let's do another example with this situation, slightly more complicated. Here's the prompt. What's the probability that random variable x is less than 2? What does this mean? What is the probability that this person wakes up on time less than twice in a week? So this one, we're just going to have to calculate the probability for wakes up on time once and wakes up on time 0 times, add those together, and that will be our probability. So pause the video, see how far you get with that. 2 steps for you. First, the general step. Here's what we're doing. It's our roadmap. What is the probability that random variable x equals 1 wakes up on time once? And we're going to add that to the problem variable, the probability that the random variable x equals 0, which is wakes up on time not at all. Okay, so I put in the plug-in step here. Here's the combinatorial calculation prompt. How many ways can we get 1 time out of 5 total? And we multiply that by the probability of waking up on time to the r, and then this one is the probability of not waking up on time to the n minus r. And then the same thing here. Boo-boo, boo-boo. What goes there? That's 5, 0. That's a plus. Okay, so here's our combinatorics for that one. 0.9 to the 0 power and 0.1 to the 5th power. Now, if you haven't gotten further than this, pause the video and find that probability. All right, let's do a review of how to calculate this, the 5 over the 1 combinatorics, because I have a little shortcut for you. So check this out. here's what it is. 5, 1 is 5 factorial over 1 factorial times 4 factorial. Now I don't have to break the 5 all the way out. I can just do 5 times 4 factorial and leave that there because I know I'm going to cancel with that 4 factorial. So this cancels those away. 1 factorial is just 1, so that makes this just be 5. So you can go a little quicker if you don't factor out all your factorials. So now let's take a look. So I put my 5 in there. I did my 0.1 to the 1 power is 0.9. I did my 0.1. I did my 0.9 to the 1 power, which gave me 0.9. I did my 0.1 to the 4th power, gave me those. Did the same thing here. Remember, whenever you're doing a combinatorics with a 0 on the bottom, you just make it 1. Okay, so you just got to remember that, and then I multiply it out. I got my little pieces here. I add them together. I got a big long decimal, and then just for kicks, I converted it into scientific notation. Action. All right, let's do a slightly different example. Here's one drawn from real life. There's a certain drug that has an 80% success rate. It cures people 80% of the time. Not too bad. We have 2 groups of 10 patients each. What is the probability that all the patients in both groups are cured? So we're going to give each of these groups the drug, and we want to know what is the probability that all those patients are cured. And we have 2 groups. So we have 2 different sets of data. So what we're going to do in the first time is we're going to calculate the probability for just one of those groups, and then we're going to use that result to figure out what the probability of getting everybody cured in both groups. So we're needing to find the probability of random variable x equals 10. Now pause the video and tell me what these variables are. So the number of trials is 10. We're trying the drug on 10 different people. The success that we're looking for is 10. We want all of those to be success, and our probability of success on any one person is 0.8. So now pause the video, do your plug-in step, and calculate that probability. Here's my plug-in step. Combinatorics, 10 over 10. We have 10 trials and we want 10 successes. Our probability of success is 0.8. We're going to do it to the r. And then finally the probability of failure is 0.2, and this is the n minus r. 10 minus 10 is 0. Okay, so 10 over 10. Let's take a look at that combinatorics-wise. This is 10 factorial over 10 factorial times 0 factorial. You have to remember that 0 factorial equals 1. Don't let that make you think it's 0. It's 1. So 10 factorial over 10 factorial is just 1. So check this out. There's my 10 over 10 combinatorics. That's 1. And then I have 0.8 to the 10th, 0.2 to the 0. Crunch those numbers. This thing is really just 0.8 to the 10th power, and that's 0.107. Now, I want you to pause the video and think real hard. How would you use this result to find the probability that both groups have a 100% cure rate with this particular drug? So you just had to remember that when you have 2 independent events and you want them both to be true, you just multiply the probability of one independent event times the other independent event, and that gives you the probability that they're both true. That's the intersection. So I just multiply my probability that everybody was cured in a 10 trial times the same probability, and I get 0.115 for my probability that all 20 patients, 10 in each group, are cured by our drug. Now that you've watched the video, take a moment to write down some notes or questions or a short summary of the lesson. You can also re-watch portions of the video that you didn't get so well the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.